We are going to build a JWT Authentication web API from scratch together. Hello and welcome to Code with Sar. I'm Sar. In today's video, I'm going to show you how to build a web API that is protected by the JWT token authentication from scratch. I'm going to use SQLite as the database. I'll use Entity Framework code-first approach. And I hope to use this example as a supplement for all the JWT theories that we have been talking about. What I want to say up front is, I spent quite a while to build this sample up. Don't worry if you cannot follow what I'm doing all the time. If you follow the video to the end, you'll see everything coming together. And I'm going to share the code through GitHub. And I highly recommend you to follow the example, check the code out there, and try to do it yourself. This is going to be a relatively long video. I'm going to put them into sections so that you can jump back and forth freely. Okay, well that's it. Let's dive in. Let's go over the functionality of the system that I'm trying to build here. The first one is about the weather forecast, which is actually comes along with the web API template. The only difference is that I'm going to protect the API with the authorization. When it's built, only requests with the user role can access the API. The second piece is about the registration of the user. The user will be able to type in their username and password to sign up for a new credential. The third piece is about user management and role management. Things like listing all the users, listing all the roles, do role assignments, and so on and so forth. Only admins can do these actions. Okay, let's get started. Let's start with the database design. Firstly, we will have a user table. In it, we're going to give it an ID for the user, then username, password hash, which is a byte array, and it's active. This is going to be used to mark the user as inactive, so that we can choose to disable user rather than delete the user. The second table that is useful is going to be role. Similar to the user table, we're going to give it an ID, which is a GUID, auto-generated. There's going to be the name of the role, like is that a user, is that an admin. Then we have this is active as well. Now let's consider the relationship in between the user and the role. It is obvious that a role could contain multiple users, like there could be multiple admins, there could be multiple users. Can a user have multiple roles? I would think so, because a user, well, we could have a kind of like an account that acts as the user at the same time as an admin. So it's a many-to-many relationship. And in an RDBMS system, many-to-many relationship is represented using a third table. Let's call it role user, and it will have reference to both tables. Again, using these three tables, we can form up a many-to-many relationship in between the users and the roles. Let's see how to create a database like that. I'm going to use code-first approach with Entity Framework. The first step is, of course, to create an empty web API from the templates. Let's name it jwt.example.withsqldb, and the output folder would be current folder. Then bring up VS Code, and we're going to put the modules on the folder named modules. The first class that I'm create here is going to be the user. It's going to be a POCO class. POCO stands for plain old COR object, which is actually a normal class that has nothing to do with the entity framework. I'm filling up the properties into this class from the design we have. Remember, one user could have multiple roles, so I'm going to put a list of roles down here when we have that class. And ta-da! Created the role class, doing the same thing, and I'll complete the role list here. Now that we have these entities of user and the roles, it is time for us to create a DB context. A DB context is an entity framework concept. It maps to a database. To create a DB context, firstly, we need to reference this package. You might notice it is for SQLite Of course, that's the database that we're going to use. You can use your own database. As long as you have the table and you have the DB context, you should be able to follow this example. Now let me create my UserDB context. This UserDB context need to inherit from DB context, which is provided in the package that we just added. Next, I'll create a DB set of user as well as a DB set of role. These DB sets will be mapped to tables in the database. Other than that, we also need to override this onConfiguration method to provide the database information. Here I'm going to create a database named UserDB.db in the current folder. Now we have the class models. Next, I'll show you how to generate a database based on these models. First, we need to install a tool called .NET EF. EF for Entity Framework, of course. As you can see, I have it installed already. Next, we'll need to add the package named Microsoft Entity Framework Core.design. This is a different package than Entity Framework by itself. This one will read the DB context and generate scripts that can be used to create a database. And those scripts are called migrations, and you'll see that soon. The third step is to generate the migrations by calling .NET EF migrations add, and then give it a name. I'll call it initial grade here. Once that's done, pay attention to this migrations folder. You'll find these so-called migrations actually code to run to create the database. For example, in this initial create, which is the name that I've given just now, there are two methods, up and down, to create or drop the table respectively. Let's browse this code really quick. We have code to create rows, and we have code to create including the primary keys, and then we have code to create users, ID, name, password, hash, different columns, and then constraint of primary key. And since it's a many-to-many relationship, there's code to create the table for the relationship as well. The last step is to execute the migrations to create the database. To do that, we need to run .NET EF database update. And after the step, you'll see UserDB.db being created here. Let's crack open the database and see what's in it. As you can see, all three tables that we defined in the classes are generated. We have the database sorted out. Now let's design the service on top of the database. For demo purpose, the service is going to be relatively simple. What I'm thinking is we're going to have a UserDBBase as a base class for the concrete services. Then we will have a UserService that inherits the UserDBBase. And it will have concrete methods like add user, get users, get a specific user by ID, so on and so forth. Of course, to get a list of roles the user belongs to, we could throw in a method called getRoles. And with regarding the role service, we could have a simple adding, getting methods like this as well. And one of the interesting one would be do a role assignment. That is putting a user into a specific role. And that's pretty much it. Let's create the services. As we designed, the first one is going to be UserDBBase. This is an abstract class that will be derived by UserService as well as a role service. This service is going to do nothing but hold an instance of the UserDB context injected by the dependency injection container. If you don't know what a dependency injection is, I highly recommend you to learn it first. And I happen to have a series talking about that, and I'll put a link on the right upper corner. Okay, come back. The UserDB context does not need to be accessed outside of this class, so I'll change it from public to protected. And that's it. Let's move on to the user service. The user service inherits from the UserDBBase. Then it can access the UserDB context that is provided by the base class. Let's refresh the design a little bit. Okay, I'm going to build the add user together with you, and then I'll put in some magic. To add a user, I will take the username, and then I will hash the password. Here I'm adding the user to the UserDB context. The reason that we can do that is because we have a DB set on this DB context. Here, I want to point out, when we save the DB context, the user will have an ID generated, and it will be put onto this same object that will be returned. Let's take a look at the compute password hash method that I left out a little bit earlier. I'm going to use a simple SHA-256 do a hash, but I don't have a sort or anything like that designed. In real production system, it is always a good idea to put a sort for the hash of the passwords. Here, I want to transfer the password from string to string. This functionality is generic enough and it could be reused. I'm going to write an extension method on the string. Now let's do it. Okay, we created the one method together. The rest of it is about implementations. It's all the same. We just manipulate the entities on the DB context, save it, and do the return. Everything like that. To avoid boring you, I'm going to just copy over the implementations that I've done before. And that is happening now. Oops, it seems like there's some compile error. I must have made a mistake somewhere. Ooh, it seems like I forgot to rename it. Everything's in green now, I like it. The service is in place. Let's design the API. These are the APIs that will be exposed by various controllers. And I'm going to focus on two aspects of the APIs, the routes and the methods. For example, to manage users, we're going to have routes to/users. When the request comes in as a HTTP post, we're going to create a new user. This will be useful when we register new users. And then I'll implement an HTTP GET to list all the users as well. For a specific user, I'm going to use /users/id to identify it. And when the method is HTTP GET, we're going to return the information for the target user if it exists. I'm thinking to use a patch method to update the password. Then we'll have similar rules for roles. And we're also going to build a /token route for returning the access token. That's about the surface of our APIs. Okay, code with me to create a user controller here. First, let's create a controller class. I'll call it UsersController. Here I'm carefully match up the name with the root that I want, so that I can use the controller in the root template. A WebAPI controller derived from ControllerBase. This root attribute marks down the root to this controller. Since my controller is named UsersController, the root would be /users. Also mark this class as an API controller. Next, let's create a constructor to inject all the services that we need. In this case, the UserService and an iLogger. Then, I'll create a method to list all the users. Since this method is going to have the same root to the controller, we're just going to put a root empty here, and then the HTTP method of get. It does pretty much nothing but get all the users from the UserService. Next, let's create the HTTP post method to create a user. Whenever we create a new user, we would need some inputs from the client side. Imagine a simple sign-up page. You would want to ask the user for the username and their password. The way I usually implement it is to create a separate module to taking in the inputs. The benefit of doing this is that I can put other annotations on the properties and let the web API to take care of the validation. Again, since we spent the time and the effort to build the service, the controller becomes very focused on getting the inputs from the user, and there's not too much logic here. This is desired. Believe me, you would not want your controller to be the dump of logics that cannot be reused. For creating new objects, there are several conventions. For example, the return code will be 201, and also in the header, usually we will involve a URL to the created object. In ASP.NET Core, this created@action action or created@root methods are used for that purpose. It requires the action to be there to figure out the URI, so I'm just going to create an empty method for that purpose. In case of exception, by any chance, I'm just going to log it so that we will see it in the backend. And for the front end, we're just going to return something like a conflict or something like that. So far, we have designed and built the database, the services, and the controllers. It is almost time for us to put it into use. But first, we will need to register all these services. Cool. Let me put up some breakpoints and let's start a quick debugging session. The very first API that I want to hit is this /users. Imagine that I am the administrator of the system. I want to check and see how many users is there in the system. This is where I go. This gets the controller. The controller gets the service. The service queries the DB context, which queries the database in turn. And then it returns the results. Of course, in this case, it is empty because we don't have any user here. Let's line one up. Pay attention to this request. The method is HTTP post. The root is /users. And I am providing the username and password in the body of the request. This matches the design for us to create a new user. Now pay attention to the response when it is successfully created. The status code is 201. The original object is returned in the body, and there is this location header for us to get the user's information. Now, if we try to run HTTP GET on the /users, we're going to get one user listed. Now that we have everything built, I'm going to show you how to put this together with the JWT Authentication. To do that, we will need to implement this /token root again. Since we have implemented the same code in the other video, I'm going to take it further here to refactor it so that we will have a service for access token. I plan to call it TokenService, and it will have a method called createAccessToken. Let's check out the implementation. I'll start by copying the code from the other place and to see what needs to be changed on the way. The first thing I noticed that is missing here is to add in reference to the NuGet packages. Here we'll need a new model to take in the user input. I'll call it user login model this time to align with user register model. It also has username and password, so I'm going to copy them from the user registry model. The reason that I don't want to reuse the class is because conceptually they are different. This getAccessToken method should come down from the TokenService. The token service is probably going to rely on the user service and the role service that we built before for user validation and the role validation. Let me inject them here. Let's assume we have the token service fully built. We're going to inject it here into the controller so that it can be used. Now let me copy the body of this getAccess method and paste it into the token service to see what change is needed there. It first validates the user, and we have a service to do that now. Next is about creating the access token. One thing that I want to mention is we still have issuer and the audience as a loose string here. In production code, I'm probably going to send them into an option. But here, I'm just going to leave them as is, since we already have a lot of things to pay attention to. Now, the core of this method is to coming up with proper claims based on the user information and the role information. And I'll clean them up a little bit. Here, the signing credentials requires a secret, and I'm going to quickly put that into an option. I'm going to use the section name of JWT Auth, which will be mapped to the configuration file. For the token service to make use of the option, we need to configure it here so it will get the value from the configurations. Here I'm going to inject the option that we just created. Now let's set the value for the secret for our development environment. I'll just pick up a random string on the screen. Okay, we pretty much are finished refactoring the JWT token service. Let me go over the code a little bit just to see if there's corner cases that need fix. Oh yes, I changed the getAccessToken method to asynchronous method. Okay, we have the service built. Let's register it and also enable the authentication authorization. I'm copying the code from the other video again. Here, we will need to get the secret for signature validation. Let's run and see it in action. Post on /token to get the token, and it seems like it's getting the token back correctly. Let me quickly decode the token and give it a validation too. Okay, now the token mechanism is working. It is time for us to start to protect our endpoints. For all the operations on roles, only admin can do this. When the time the client is request for a token, they don't have an access token yet. So this API is going to be allow anonymous access. User tokens interesting. Most of the operations like list users also requires admin role. However, we need to allow anonymous user to register a new user. So I'm going to put an admin role requirement on the controller while apply the allow anonymous attribute on the add user action. Finally, for weather forecast, I'm going to only allow user to access it, not the admin. Of course, this is just an example of the authorization rules. Different systems definitely going to have different rules. Let's spin up the Postman and give these rules a try. First, let me try to get a list of users without any token, and this is going to yield 401. Now I'll use the admin credential to get a token. Let's quickly decode this token and just see what's in it. Other than the sub of admin, it's the username, we also have a role of admin for this token. Let's query the user again. Since admin is allowed to access the list of users, this one returns the list of users. Pay a little bit of attention to this user, it doesn't have any role assigned at this moment. That aside, I'm going to use this admin token to list all the roles. And that went well. Now let's try the role assignment API. We can to grab the user's ID and the role ID so that it can associate these two. Oh, this is for one because I didn't paste in the access token for admin. So to the web API's perspective, this is the unauthorized request. Let's pause and think a little bit here. This one actually reveals a very interesting characteristic for web API, that it is stateless. The request you send now and the request you send before, they are totally separated. That is why on the client code, once authenticated, you need to put the access token on every each requests. Now it works. Let's actually query the user again just to verify the role assignment succeeded. The user star now has a role of user. Next, as a final test, I will hit the weather forecast rule twice. once using the admin token, which expect to be failed, and then I'll hit it again with the user of SAR, and that one should return us the result. Thanks for watching. I hope you enjoyed it, and I hope you have more understanding around how JWT authentication works. Press the thumb up to let me know if you like it, and subscribe if you want to watch more videos like these. I'll see you in the next video. Until then, take care.